Hello students. So this channel is your UMBIB concept by Nidhi Agrawal, and in this tutorial we will going to extend tutorial number 6 on floating and sinking. That chapter belongs to our ICSE 8th class. Chapter name is Physical Quantities and Measurement, chapter number 2 of physics. Okay. So in the previous tutorials we have discussed about the density, relative density, their numericals, as well as anomalous behavior of water. If you want to understand those concepts, so you can refer all my previous tutorials and all the links I have given in the below chart. Okay. Now here in the floating and sinking, what is the meaning of that? That means which one is going to be float and which one is going to be sink, on which basis, on which conditions we can say. Okay. So here first one we are just writing that it's a floating and sinking. Okay. So for example here, if just suppose that if something is given to you as one substance and as two substance, as one substance density is more than the S2. So density is less. Okay. So right now we are just hypothetically try to understand in between of two substances like S1 and S2. If the density is varying, which one is going to be float and which one is going to be sink? That we need to understand. So floating, that means what? Here I am making a rough diagram for you. So for example, this is your water trough. And if I am floating a one paper piece on it, one paper piece. So definitely it will going to be float start in, that means in the start of minutes. After that it will going to be soak and become more denser and make it down. Okay. Or we can say a very thin film of a plastic. Okay. So what? Thin film of plastic. Okay. That will be going to float. Float on water. Okay. Now in this case, where the sinking we need to understand. So for example, this one is your another example and this one is your water. Okay. And rather than of that chip, we are using a one nail. Okay. With the different color. Iron nail, for example, this one. If I am dropping on that, it will go and drop themselves down. Okay. That means it will going to be sink. So what does it mean here? Whatever the material we are understanding here, we are trying to understand in the terms of a floating and sinking, that need to be lighter than the water in the case of a floating, that need to be heavier in comparison to the water density. So that will going to be sink. Okay. So here we can say ds1 is more than ds2, and in that case that means the less denser one gets float. Less denser one gets float. That means which one is this? ds2. Okay. And just suppose that we are saying it is a ds2. That is going to be float on. Now after that, another example we can say here. ds1 is lesser than ds2. Okay. Here we can say that high denser one gets sink. Okay. And what was the example here? That means what is the condition here? ds. Okay. For a while we can, just to make a difference, ds3. So this one is also a ds3. So ds1 and ds3. Okay. And what you can say, this, which one is going to be sink it down? This one. So this one is your what? Substance 3. Okay, and that substance 3 having a density of a D. So here the same thing we can explain. Just a minute. S2. Okay, so this one. Now we can understand this thing with the one example also. So for example, what? For example, solid iron ball. We are taking an example of a solid iron ball. Iron having a density of what? That is a given. And you should also remember that because it's a very common example. So 7.86 gram per centimeter cube. This is a density of a iron. Okay. Now we need to understand it will going to be sink into the water or float on the water or float on something else. Why? So that means iron is definitely going to be sink in water. Why? What is the reason behind it? Because we already understand in the previous slide that all thing depends on the variation in a density, how much difference they have. So here density of iron is your what? 7.86 gram per centimeter cube. And what is the density of water? H2, you know that already. 1 gram per centimeter cube. So here, because density of iron is more, DFE is more than DH2O. That means what? The iron will going to be settled down, or we can say sink into the water. So iron ball gets sink. Okay. Now the another example we can understand here. Floats on mercury. Mercury chemical formula is your what? Chemical symbol is your what? Hg. Okay. Now you know already here from this one. Density of iron is your what? 7.86 gram per centimeter cube. Now what is the density of mercury? 13.6 gram per centimeter cube. Okay. So these are the values. Now you can easily understand which one is more heavier, that means more dense, mercury. So that means here, if you are comparing density of iron and density of mercury, so which one is heavier than this one? Now this one is your different situation because in the sink in water condition, iron is more denser than water. But in case of a mercury, filled of a mercury turf, at that time mercury having a more density in comparison to the iron. So what is the result of that? Iron will going to be sink or float? Definitely iron ball gets float on mercury. Okay. So these are the points, and this is your actual very important concept to understand. You can stop the video and write all the notes that I have explained you. Now the next one is your word. What is a principle of flotation? That means what are the factors actually working on them at the time of a flotation? Just a minute, spelling check. Flotation. Okay. Now what is the object in that concern? What is our object? That means when that means what is a target at the time of a flotation? What we are actually thinking first? So that means when you are talking about object, when it is completely or partially immersed in water. In water. That is the important thing here. Okay. Now, how many forces are actually working on this object at the time of a flotation? Two forces will going to be work. Two forces will going to be applied. Okay. So you just note it down. Now after that we will going to understand how many type of forces actually that object going to be feel at the time of a flotation. Okay. One is your what? For example, this one is your object. Any object. Okay. Whatever the object weight, that means the heaviness, that is considered as what? W, capital W. And capital W basically explains you what? Weight of body. So that W is actually applying vertically downwards. What is the meaning of vertically? For example, this is your earth surface, and anything which is working on the by making a 90-degree angle, that is your what? Vertically downward side. Okay. So weight applying vertically downwards. Okay. And W having a what? That means if you are thinking about the W, that means weight. So weight wants to be reside into the bottom. That means they want to get sink. So we can say W having a tendency to get sink. Okay. Now the another force. So for example, this is your turf in which we are performing that experiment. Okay. And this is an object. O. And this is your full of water. Okay. And the W is working downside. And whatever the water is going to be displaces. That means, for example, this one. This one is your boundary which are actually connected with the water surface filled in the water. But you can see this particular area of a water is going to be displaced. Okay. So then whenever any object drop on the water surface, so some area is going to be displaced, that particular concerning water, respective water. So that water is applying a force on that, and that force is known as by what? Buoyant force. But that buoyant force having a direction on the vertically upward. Okay. So FB, that means what? Buoyant force. F stands for force, capital F, and the B representing the buoyancy. Okay. In future, you will going to understand that concept by the Archimedes principle in your next class. Okay. Now, FB. FB is your what? Buoyant force of liquid. Okay. That will going to be applying vertically upward. Okay. Now after that, FB, that is your buoyant force of a liquid, and that buoyant force basically a what? Amount of displaced liquids by the immersed object. Please write it down carefully. FB basically a what? Buoyant force, and but that buoyant force of what? From what it will going to be applied? From the liquid only. Okay. And how much it will going to be applied on the object? That means how much water is going to be displaced from this area. So amount of displaced liquid by immersed object. Okay. Now we will going to explain this particular portion in detail. So here I can pick this one. Okay. So this one is a what? Hmm. From here. Okay. Now that will going to be explained now about the how that force is going to be applied and in how many varieties. Okay. So we can say this FB force have a tendency to move the object upside. This is actually a consequence of that force. Okay. And here that also known as by a up thrust force, because whatever the pressure on some area going to be applied and by which you can feel a pressure, that is a simple pressure definition, P is equals to force by area. But when that particular area is, and that means that condition is generating by the water on the vertically upward side, at that time we are using the word of what? Up thrust. Okay, please write it. Okay, so this one is an important point. Now after that, these type of upthrust having the three conditions: case 1, case 2 and case 3. Okay, so what are they? So case 1, that is all extension of slides. So you just write in continuation and try to make a notes. अगर आप notes बनाते हैं तो ये आपके लिए बहुत अच्छा है. केवल आप पढ़ के उसको नहीं याद रख सकते. You need to revise them. Okay. So this one is your what? That weight. Whenever the weight is greater than FB, at that time we are understanding case 1. When your weight is equals to FB, at that time we are understanding case 2. When your weight is lesser than FB, at that time we will going to understand case 3. Okay. So this one is your what of, in that the water is filled in all the conditions. Okay. Now one by one we will going to understand what will happen in this condition. So whenever the weight is more than buoyant force, that means the displaced liquid is not applying that much amount of a force in comparison to their weight. So what will happen? It will going to be sink it down. Okay, it will going to be sink it down. So for example, this one is your what? This one is your what? W. Okay, and this one is your what? FB. Okay, and that is something solid block kind of a situation. Okay, so resultant force is your what now? W minus FB. That means that condition has been generated in what sense? When your density of solid is greater than density of liquid. So in that situation, the things will going to be sink. Okay. Now this one is your what? Completely filled. What? Now here, in this case, for example, This one is your block S, and your water is completely filled here, like this. So what you can observe in that condition, whatever the weight is going to be a down, whatever the buoyant force is going to be up, okay? But here the resultant force is what? Is 0, because W and FB are equal to each other, okay? So in that situation, density of solid is equal to the density of liquid, and in that system, that means in that condition, the block will going to be float out, okay? Now in another condition, third case, I need to rub it down little. For example, this, and this one is your block, this one is your block weight, this one is your FB, and this one is your water filled turf, like this. Now what you are observing here, so here you can easily understand that density of solid is lesser than density of liquid. Yes, so that here the density of solid and density of liquid is equal to each other, like ice and water approximately, okay? So it will be going to be look like that only. But whenever the density of solid is really very light in comparison to the density of a liquid, so that situation will occur. That means what? Body will float partially above the surface of liquid, okay? So this is the meaning of the cases here, and definitely it will give you a clear understanding, okay? So these points, it's clear on the cases, case 1, case 2 and case 3. So that means if you are discussing on the basis of this understanding, what is the law of flotation? So weight of floating body W is equals to weight of liquid displaced by immersed part. That means what? That will going to be apply a buoyant force. So W is equals to FB, that representing what? Flotation. Okay. So that representing what? Flotation. Now in the next slide, law of flotation. So here weight of floating body is equals to weight of liquid displaced by immersed part. That means that is buoyant force. That means what? FB. So here W is equals to FB is a ideal condition for the flotation, for the law of flotation. Now what are the conditions we need to cover here? Please try to make the all notes. It's really important for your understanding. First one is your what? Apparent weight of the floating body 0. That means what? Whatever the body is going to be float on a water, for an example. So at that time, the apparent weight, that means in general, when you are pick it up, definitely it's having some weight. But at the time of a flotation, that apparent weight, which is not real, apparent weight is actually 0 in the nature of that situation. Now, floating bodies is majorly, that means major portion get outside because of what? Because of what? Because when density of liquid is more than the density of liquid which is low. Okay, so this is our condition. So for example, on the basis of that, we can understand one more point here. For example, I will relate. Hopefully you can understand that line. If you are not able to understand that line, the previous slide, I will explain you. First, try to understand the examples. Okay. So for example, this is your water filled turf and this is your one block. Okay. So first I need to make the drawing. So it will be easy for you all to understand. Okay. So this is your what? H2O and this is your what? 10 gram wood piece. Okay. So as you see here to here, this one is your area. This is a condition where the water is going to be displaced. We can understand this by making that red color mark. This. Okay. Now another thing, another example. This is not a water. This is a glycerin. Glycerin is actually more denser than water. Okay. And this one is your block. The same block, for example, we are using here. The 10 gram wooden piece. Okay. And that will going to be filled with the glycerin. Okay. So here, as you are seeing this one, just a minute, I need to make little change in this. So for example, this one is your complete wooden block. So as you are seeing, this one is your covered area. Okay. And which one is very less? Which one is very less? This one. Okay. So this one is your less area. Now what is the meaning of that? So here the density of water is your what? 1.00 gram per centimeter cube. And what is the density of glycerin? Is equals to 1.26 gram per centimeter cube. And by the data, you can understand that density of a glycerin is more in comparison to the water. So what is the conclusion? What is the conclusion? So that means density of wood is lesser than density of water and density of glycerin. That's why it will going to be float in both the situation. Okay, so we can write that's why it floats on both. That's why it will not going to be sink it down. Okay, but the important point is this. But the important point is what? This one. What? D water is less denser than D glycerin. Due to this reason, some portion, or we can say some piece, I can write the portion, what is more appropriate. Some portion of wood piece majorly outside on glycerin jar. Why? See, so that means this wooden piece feeling more buoyant force where? In the glycerin in comparison to the water. Because of what? Because of a density variation of water and in glycerin. Okay, just write it down very carefully. Now we will move on to the another portion that is actually explains you a one numerical. So I will explain you this thing. Okay, just do it. Stop your video and do it by yourself. Now the next thing is your what? Now, on the basis of this particular question, we can understand about that particular numerical. Okay. So, first we need to read this. The table below gives the density of some solid and liquids. For each solid, list the name of liquids in which that solid will A floats and B sinks. Okay. So that we're going to discuss. So in the comparison of a solid iron, and the density is given 7800 in kg per meter cube, and the liquid is your what? Mercury. Okay. So first we need to understand one by one in the case of a iron. Okay. And what is a given density in kg? 7800 kg per meter cube. That is a given thing. Okay. We need to understand first in the case of a water, for example, or we can say in the case of a Hg, not water. So just a minute. Hg. And what is the density is given here? 13600 kg per meter cube. So in which, because the density of iron is lesser than the mercury, so iron will going to be float only. Okay. Now in another case, for example, in water, what is happening here? 1000 kg per meter cube is equals to, so water 1000 and iron is 7800. So Fe will going to be sink. And another example is your what? Cork. Cork no. It's a glycerin basically. We are using this line. So this one is your what? Glycerin. And what is a glycerin one? 1260 kg per meter cube. Now what will happen here? Fe will going to be sink. Okay. The same thing you need to apply for the wood. The same thing you need to apply the cork. Okay. So one by one we will going to understand. When wood having a 700 kg per meter cube. Okay. So we need to compare with the Hg. What will happen? Tell me. Because Hg having a 13,600. So definitely wood will what? Float or sink? Wood will going to be float. In case of a water, what is the density of water? 1000 kg per meter cube. And that is a 700 only. So definitely wood will going to be float only. Okay. Now in case of a glycerin, what is the density of a glycerin? 1260. And what is a density of a wood? 700. So definitely it will going to be float only. So in that condition, with the comparison of a wood with mercury, water, and glycerin, no condition will give you a sink situation. In every situation, wood will going to be float only. Now the next one is your cork. The same with the Hg, with the water, and with the glycerin. What is the density of cork? 250. What is the density of mercury? Definitely it will going to be float. What is the density of water? 1000 kg. And what is the density of a cork? 250. So definitely it will going to be float. What is the density of a glycerin? 1260. And what is the density of a cork? 250. So it will going to be float. In that condition also, no example, that means cork piece will not going to be sink in any condition. Please note it down carefully. Now in the next portion we will going to discuss about the application of a flotation. Okay, so that thing we will going to discuss into the next tutorial. Thank you, and stay on my channel and please subscribe it.